we're going to add polynomials. Luckily, you know how to do this already. By show of hands, who remembers how to combine like terms? We all haven't had this. Combine like terms? Oh, okay, so we have. So somebody explain to me what that means, combine like terms. What does that mean?
Well, if you have like 4x plus like 2x, you add it and you get 6x.
Amazing.
So you have like 4 xylophones and 2 xylophones, and you add them together, you have 6 xylophones.
I prefer apples and bananas.
So
So yeah, so if I have 6 apples and 4 apples, I can add those, but can I add the apples and the bananas? No, because we don't allow smoothies.
yeah.
So, well, what about, okay, so going with that, like terms mean they have to be the same thing. How are they the same? Like, can I add a 5x squared? Can I combine 5x squared and 2x squared?
Yes.
Yeah.
Yes. It
Yes.
means still 7x squared.
Can I combine 7x and 3x squared?
No.
Why not?
Because you
Bounce
don't.
it out. Why not?
Because 1 is 7x is not
Doesn't have an exponent. So what is it that makes terms alike so that I can combine them? What makes them alike?
They have to have the same kind of, like same variable, and they have to have the same exponent.
Here we go. Okay. So how about, can I have more than one variable? Can I have like x squared y cubed? Is that allowed?
No.
Yeah.
Yeah. Oh, really?
Yes, right? So if I have 4x squared y cubed, and I have a 2x squared y cubed, how many x squared y cubes do I have? 6 of them. So yes, he is absolutely right. You want to have the same variable exponent combinations. That's what makes them alike. So when we are adding or subtracting polynomials, that's all we're doing. So I've got some examples here. Let's look at the top row, which is adding. So what we want to do with these is we want to find like terms. I'm going to start with my first term over here. 2x cubed. Do I have any other like terms? Because what are the like terms going to look like? What are they going to look like?
They're gonna have the same variable on the thing exponent.
Okay, so what am I looking for now? If that's my 2x cubed,
You're looking for anything that has an x cubed in it.
and do I have one?
Yes.
There it is. Now watch
That
how I
is
circle
exactly.
it. Watch how I circle it. What am I including when I circle? What am I including? The sign in front of it, because it's going to tell me what to do. If you have 2x cubes, and then there's another x cubed added to it, how many x cubes do we have? Oh, here are all kinds of answers. I have, picture them in your hand, 2x cubes.
X cubed.
I'm giving you another one. How many do you have there, Nick?
3 2x cubed. Or 3x.
3x cubes, right? So done, we cross that out. Now let's look at the next one here. X squared, right? That's what I'm looking for. So do I have more x squared? Well, here's one. Oh, yeah. I do. So let's see, negative 5x squared plus a 2x squared.
Negative
Yeah,
3x
please don't shout out. Yeah.
Negative 3x.
Negative 3x squared. So tell me, what are we doing here with the exponents? I'm sorry, with the coefficients. I meant to say coefficients. Adding them, right? So we find the same coefficient, variable exponent there, and then we add the coefficient. All right, now I've got a plus x. Do I have any other x's?
Yeah.
I'm looking at this guy. Well, can I combine the x and the negative 1? Are they alike? As we know, what's the secret exponent on here, right? They're not the same, so I can't do that. So I just got a plus x. Done. And then I've got my minus 1. Do I have any other constants? No. So if you have done this correctly, by the time you get done here, I shouldn't be able to combine any more like terms here. But I checked just in case I missed one. Are any of these combinable? No. They all have different exponents. So we're done. And that's it. That's all it is to add polynomials. So let's try this other one here. 3x squared plus x minus 6 plus x squared plus 4x plus 10. We start with the 3x squared. Do I have a match? Do you see a match?
Yeah.
Where is it? Yeah, here it is. And look, I'm circling with that sign again. So tell me, Shalom, if I have 3x squared and another x squared, how many x squareds do I have? 4 of them. 4x squareds. Done. Let's see, I've got a plus x. I can see that plus 4x. So you have an x, I give you 4 more x's. How many x's do I have? 5x. Gone. Well, let's see. Now, let's see. Ooh, I'm seeing some matches here now with the constants because those are like terms as well. What do I get? Minus 6 plus 10. Plus 4. So the sum of those two polynomials, 4x squared plus 5x plus 4. Okay, not so bad. Who was able to follow that? Awesome. Okay, now we're doing subtraction. Now subtraction, there's kind of a step you do beforehand, and then it gets to be almost the same thing. I'm looking here at this minus sign, and I'm going to have to distribute it. Remind me what the distributive property is?
Multiply everything by the number.
By the number in front, right? Well, what number in front?
And 1.
Yeah, right, we have our secret 1. So I'm going to be taking that negative 1 and distributing it over everything inside that parentheses. So this guy that's kind of started out, he just stays. And then I look at negative 1 times negative 2x squared. Positive 2x squared. Negative 1 times positive 2x. Negative 2x. Negative 1 times negative 4. Positive. Good. Positive 4. Now let me just erase here for a second so we can kind of see what we started with. And let's compare this polynomial with the one that we just kind of worked with. Do we notice anything about those two polynomials? What are you noticing?
No, but I see the keep change things.
Okay, well, we're kind of going away from those little sayings. We want to think about what are we doing so that if we see a problem we don't know, we can figure it out. But that's good. That's fine. Yeah.
That all the, like the signs are changed. Like if you look at the first equation, exactly.
All those signs change. A negative went positive. A positive went negative. A negative went positive. So what is the effect of distributing a negative? What does it do? What does it do? Changes the signs to its opposite. And once I've done that, this is now an addition problem. Just like we did up here, we're going to do down here. 4x squared, do I have a match? Oh, here it is. 4x squared plus 2x squared, how many x squared? 6x. That's about it. Now watch what I'm going to do here. Instead of going to the number next, I'm actually going to go look at the terms that have x in it. If you go ahead and kind of add in the order that you want them to come out, you will get standard form every time. So I'm looking at this minus 2x. I think I should make it my box. More x terms that I can combine them with? Now, I don't see any, so I'm just going to write negative 2x. And then I'm going to go with my numbers. What do I do next? My constants. I like doing those last. Plus 5 plus 4 plus 9. Good job. So I am in standard form. What would have happened if you didn't do that? It's not the end of the world. You would have gotten 6x squared plus 9 minus 2x. And that's okay. It's just not in that standard form of descending exponent order. But so you would have to remember to kind of put it in there. So it's fine. Either way is good. And then let's do one more subtraction example here.
What you did do, we had to distribute because when I thought it seemed some familiar when we did another unit off. Wait, what?
We did. We have talked about multiplying 3 by negative 1 and what that does to us.
Yes, and I felt
I will tell you.
Felt like the dust was taken.
I will tell you, some people can do this in their head. They can kind of see, and they change it in their head. Is this something I recommend when you first learn how to do this? I really, really don't, because it's very, very easy to mess this up. I will go there. And how do I know? Ask me how I know.
How do you know?
Oh, I know.
You know?
I'm guessing that the first time you do this, it didn't happen to me at all. No, I never make a mistake.
You would get them messed up on the 2x part, wouldn't you?
Now, somebody's gonna help me with this. I wanna see if we have it. Oh, we have a couple of volunteers. I'm gonna go there. So what am I gonna do here? First we're gonna copy this, right? Then what am I gonna do?
Copy it again. On the other side?
Well, what do I have to do first?
Negative 3x with, yeah.
So we're distributing the negative, right? So then what?
And then it's going to be positive x.
Good.
And then plus a.
Excellent, right? So all those signs are going to turn, and now it's an addition problem. 4x squared minus 3x squared. Let's picture those 4x's. 4x squared. Take away 3x squared. We got done with him. Let's look at my x's. Negative 3x plus an x. Negative 2 of those x's. And then we look at the plus 5 and the plus 8. Plus 13, there you go.
Yep, that's what I got.
Oh, excellent, very nice. Very nice job. So
Yeah,
easy
here's one.
peasy
Well done.
lemon squeezy?
Yeah.
I didn't
Right,
even
now-
multiply this before.
So, this, a little bit of practice, right? But basically, you've done stuff like this before, where you add the terms, you look for those like terms. Maybe you didn't see it presented this way, but that's all you gotta do. So now we're ready for the next one. Multiplying polynomial. Now, here's the good news. You know how to do this too. Yeah.
Nice.
Look. What does this say? What does it say? Distributive property. Who knows how to do the distributive property? Every hand should be up here. I've seen y'all do it. So you can do this. So I'm talking first about multiplying a monomial by a polynomial. What do I mean by that? Here's my monomial, so one term, by something with many terms, right? My polynomial. So distributive property. This goes here, that goes there, that goes there, that goes there, right? Nothing new. What is a maybe tiny bit new? We've been working on those laws of exponents. So here's where they come into play. The first thing we're going to multiply is 2x cubed times x cubed, right? What is that? And the way you deal with these is you kind of think of the numbers here. I only have a 2, right? That's a 2, that's my number. X cubed times x cubed. I want you very carefully thinking about it. 3 factors of x times another 3 factors of x. How many factors of x?
9.
Let's count them.
Oh, 6.
6, right? That's 6 factors of x. So that's my first distribution. Now I'm going to do the next one. That's a plus. 2x cubed times 3x squared. So let's see here. 2 times 3. 6. X cubed times x squared. What's it going to be? X to the what? Fifth. Very good, right? 3 factors of x, 2 more factors of x. I have 5 factors of x. Now we're up to this one. 2x cubed minus 2x. Well, this one's going to be a minus, right? Positive times a negative. And that's going to be 2x cubed times 2x. 2 times 2. X cubed times x. How many factors of x? How many? 4 factors of x. That's x to the 4th. And then my last one, 2x cubed times 5, right? Times that 5 there. What's that? What is that? 10x cubed. I don't have to do anything with the x cubes. So here it is. I have multiplied that out using the distributive property. So you know how to do this. We're still kind of working on this. I was looking at those checkpoints. We're still working on the laws of exponents. But I really want you to think about what is multiplying variables with exponents. It is counting how many factors you have. So think of it that way. Be very conscious of it when you first start working with it. I promise it will become easier the more you do it. So questions on this? Maybe you have to practice it, right? But we get the process. All right, let's look at this now. Because that was multiplying a monomial by a polynomial. Well, what if I have 2 polynomials in the kind of a strict sense of the word, meaning more than one term?
Mind blown.
So here I've got, I guess, 2 binomials that I'm trying to multiply. And so I have to figure out how to do it. Now the idea is everything has to get multiplied by everything else. And here's how we're going to do it, this idea of multiple distribution. So here's what you're going to do. You're going to look at this x minus 4, and that's what we're going to be multiplying. I'm going to cover this up, the minus 4. And I see the x and the 2x. So I'm basically distributing the x first. So what's x times 3x?
2x.
Oh,
Box,
x
yeah,
times 3x. And again, I want you out of autopilot. I want you always thinking. So 3x squared, right? There are 2 factors of x. What about x times 2?
Hey, 2x. No, it's
X times 2 is just 2x. All right, once you have done that one, now you cover up the x. Now if you look at how I'm covering it up, the minus is still showing, right? So what am I distributing that minus 4? So the minus 4 gets distributed over the rest of the term. So what's minus 4 times 3x? What is it? Negative 12x. So we continue building our solution here. What is minus 4 times 2? Negative 8. So I pretty much guaranteed that I multiplied every term by every other term by using this multiple distribution. Now when I look at what I got here, is there anything else I can do? Yes. What else can I do? Yeah, I've got some like terms in the middle here. They're both x's. So nothing else with the 3x squared. What's 2x minus 12x? Minus 10x, and then the minus 8. So here is my product after multiplying those two things. Now what if this had been x squared plus x minus 4 times that same thing? What do you do if you have more than 2 things that you're multiplying? What do you think you're going to do? What do you think we're going to do?
Distribute every single one.
Exactly. Now I'm going to cover up these 2 things, distribute the x squared. Then I kind of forget those 2, distribute the x. Then I'm going to distribute the negative 4. So I can basically multiply, n terms here, n terms there, and I can figure out what I need to. Now to get along a little bit more complicated, but we can do it. Does this make sense? Who's with me?
Maybe.
You guys are so awesome. Is it going to take a little practice? Yes. Now, I have to introduce this other concept here called FOIL. FOIL is an acronym. What's an acronym? What's an acronym?
Like, not like cheating, but like just to remind you.
What?
Well, we can use acronyms to remind us of things. What's an acronym?
It's like a group of words put together and then the first letter of each word.
Take the first. Do you have an example?
Like in English, capitalization, usage, punctuation, and
Okay. How about a math one?
PEMDAS.
PEMDAS, right? We got that one. Scuba is something about underwater breathing apparatus, right? We've got a bunch of them. Yes, one last one.
TBD, to be determined.
TBD. We have a whole bunch.
TV.
Now, FOIL.
Television.
FOIL is another acronym. Excuse me. FOIL is another acronym, so let's see what it means. FOIL stands for first, outsides, inside, lasts. And what it is, it's a little kind of method to remember how to multiply 2 binomials. This only works with 2 binomials. Remind me what a binomial is. What's a binomial?
a polynomial with 2 terms.
All right, so here's an example of 2 binomials. Right? It looks something like that. Here's a bigger example, a plus b, c plus d. So the way FOIL works is, you go to the firsts. What do they mean by firsts? The first term in each binomial and you multiply it, a times 6. Then you go to the outsides. What's the outsides? I have a bunch of it from here. That's like from here to here. They are on the outside of the things you're multiplying. So that would be AD. Then you want to go on the insides. Well, where are those insides? They are right here. That's BC. And then we go to the last one. There are those. They're over here. BD. And then I get my product. And if you want to look at this, if you were to do multiple distribution, say we covered up that B term, you would have AC plus AD. And then you cover up the A, you get BC plus BD. You get the exact same thing. Do you have to use FOIL? Absolutely not. But some people prefer it. And to be honest, this word FOIL has been around for at least 107 years when I took algebra. They use the same thing. They use the exact same word. So I would not be surprised if you're sitting in an Algebra 2 class in a couple of years and they say, just go ahead and FOIL it. So if I don't tell you what it is now, you'll be like, excuse me.
I need FOIL.
What?
I need
So let me just show you
FOIL.
an example. Let me show you an example of
I
FOIL.
just don't understand.
You do the first, x times x. You do the outsides. Well, that's x times minus 3. You do the insides. That's 2 times x is 2x. You do the last terms. 2 times negative 3 is negative 6. Okay, so that's using first, outsides, insides, left. You would get the exact same results if you just use multiple distribution. Cover up the 2 and distribute, cover up the x and distribute. Now what are we noticing? Right, we have some like terms, minus 3x plus 2x, minus 6. Very often you will find these, that the outsides and the insides will combine. I call that the OI, because it's outsides and insides. So don't forget to combine your OIs, because very often you have to. All right, questions? Comments? Yes? FOIL method, we'll do a different one. Let's do it up here. 2x minus 3 times x plus 1, right? 2 binomials, we can use FOIL. So you look at the first term, the 2x times the x. So it's 2x times x. What is it? Silence. 2x squared. Then I look at the outsides, this 2x times 1. What's 2x times 1? Then I look in the insides, minus 3 times x. Minus 3x. Then I look at the last, minus 3 times 1. Negative 3. I combine my OIs. 2x squared minus x minus 3. Now, if this is confusing, there is no law that says you must learn the FOIL method. I personally think covering up the 3 and distributing the 2x, covering up the 2x, distributing the negative 3. I think that's easier to see. So by all means, you don't have to use FOIL. Go ahead and use the multiple distribution. You'll be doing the exact same thing. Okay? It's just some people like it. That's the only reason it's here. Plus, you'll hear about it and you'll be like, what are you talking about? What is that? Okay, so are we ready to do some new tries?
What is your
yes,
best
question?
What is an situation in real life that you
Oh, I'm so glad you asked that. When we get to the U tries, which we're going to do next, here's a situation in real life where you will be doing some work with this.
Looks like